So Andrew, for your introduction, right?
Yeah.
UW-AOS.
Yeah. We don't get technical.
There's a weather station.
There's a what?
Just a weather.
Go ahead.
Like a WFO?
All right, welcome everybody to Weather Watch, the last one of October. I am not Dr. Martin. I am not one of Dr. Martin's students either, and I never had him for a class, I don't think. But anyways, they're all at the Cyclone Workshop today, and welcome to our alumni that are here. There's pizza in the back. And speaking of alumni, we have one of our alumni who has generously offered to help lead Weather Watch today. Andrew Quigley got his bachelor's degree here, and then he got his professional master's in the first class of our professional master's program. So welcome, Andrew. We look forward to that. And Ian Beckley is going to start the discussion with the observations. So welcome again. Grab some pizza, and those of you online, no pizza. Sorry.
I love it. Thanks, guys. Thanks so much for coming, even though Mr. Martin's absent. Just going to kind of give you guys a couple interesting tidbits from stuff that I saw while preparing for the day, and I'll kind of let Andrew take it away after that. He's actually a professional meteorologist, so has a little bit more of a probably structured approach than my laissez-faire one. So, as usual, sort of starting out with sort of a hemispheric view of the IR satellite. Some interesting things going on. Here is basically a convective complex that will soon exit the coast of Mexico and become Hurricane Christy here. You also see sort of a convective complex over the Caribbean, which moves north and east and becomes sort of a mid-latitude flavored subtropical low, taking on a T-bone shape there as it reaches New Brunswick. So those are basically the two heavy hitters in play. As we move forward in time here, give it a moment. Here's our convective complex again. This will become the T-bone cyclone up the coast. And we have a little one last weekend, and now we just sort of have this wimpy cold front and another wimpy cold front, which gave us some stuff last night. Here you go. So first off, I think we've got to talk about the amount of moisture that's in the tropics right now. So I'll just bring up one of my maps. So why is Christy there, and why is this convective complex that became our T-bone cyclone off the coast? Why are they there? Well, there's just an insane amount of moisture in both the Atlantic and the tropical North Pacific. This kind of correlates with the really, really high heat content that both those basins have seen this year. This sort of led forecasters to really promote a big hurricane season in this region, and the moisture certainly speaks to it. One of the big things with Christy here, it's not only got the most moisture in the game, but it also hasn't reached the mid-latitude shear yet, right? So the red dashed lines, these are the 1,000 to 500 millibar thickness. Christy's still well to the north there. So no problems from shear, plenty of precipitable water. That's a recipe for kind of a runaway tropical cyclone. And in the coming days, we'll start to see this move to the north and to the west. And as it nears the contours of 1,500 millibar thickness, it starts to encounter that shear, starts to break down the structure of the cyclone, and you'll start to see it degrade down to a depression or a storm status. Okay, let's focus on Christy again for a second. I'm going to back out of there, back to the room PC. Go to tropical tidbits. So here we are. This is sort of a precipitation product with the sea level pressure here. There's Hurricane Christy. We're going to cut a cross section through it. Make sure I'm on the right left there. Okay, we'll start out with potential vorticity. Remember, the potential vorticity is a product between the absolute vorticity vector and the distribution of isotropes, or potential temperature. So it gives you an idea of both the spin as well as the stratification of the atmosphere. And this is a classic hurricane picture. You just see cyclonic vorticity all the way in a tower, and that you'd like to see that tower vertically aligned. If it's tilted over, that's a bad sign for growth. We like to see it really, really nicely towering like this. And these green lines are the potential temperature, and you notice that they dramatically bow down at the center of that hurricane, and that's the warm core of the cyclone. It's warm on the inside. This makes it disparate from the mid-latitude cyclone. Cold core versus warm core. We're very clearly warm core because of the divot of those isotropes. So the other component of the hurricane, though, is it has to have a central maximum in moisture, ideally in the lower troposphere, but it can sort of just be throughout the column. So if we thought about this in terms of theta E, we'd expect lines of constant theta E to run in towards the cyclone, shoot straight up towards the tropopause, and then make a shape out. So we're seeing these, we should see concentric views. So let's cut the same cross section and see how we're doing with moisture. Cutting our cross section. We'll have theta E in this one. So now the shading is vertical motion, so you see sort of there's a tower of ascent through that warm core of the cyclone. And these are now lines of constant theta E, so we have the 335 Kelvin line. It's very messy, but here's 340. And you see that it sort of makes a U shape. And this indicates that we have a nice organized maximum of theta E. And I like to think of this, I think Professor Tripley, emeritus professor from here, coined this term, if I'm correct. He calls it the moist entropy current. He says that lines of constant moist entropy flow into the cyclone, straight up to the tropopause, and then they flow outward. That's the moist entropy current. This is how we transfer heat from the ocean into the atmosphere, through that current. So that's a pretty, as John would say, that's a gangbusters tropical cyclone. Another one I want to point out here, I'll go real quick back to the moisture that I was showing. So in Angel's lab, we like to talk a lot about moisture modes. These are small mesoscale convective systems that thrive on the amount of moisture, and specifically they like to thrive on the gradient in moisture. And so you see here, throughout the subtropics and heading into the deep tropics, we have a really strong gradient in moisture from effectively 0 centimeters of precipitable water to almost 10 centimeters of precipitable water. And this is a region where in the southeasterly trades, little convective structures like to ride along that moisture gradient. And so as they move, the convection fires. You like to have a little bit of inertial stiffness, which is why we like to have it outside of the deep tropics. And they like to ride along this, this moisture gradient. So let me pop back to the satellite view. Give me a second. Uh-oh. There we go. So you see, here's Christie, still forming, but here's that line where we have that moisture gradient. You just see there's dozens of them, just little convective structures that just march along on that gradient. And these are important phenomenon for folks who live in the tropics. This is how you get day-to-day variations in rainfall, but it's also the seeds for tropical cyclones. Something like Christie kind of began as one of those convective entities. So that's a really interesting area of study that some of my colleagues do. Okay. Today, in the local area, perhaps not as intriguing, but you got to check it out nonetheless. Here's the most recent satellite observations. Cold front, kind of just reaching the western shores of lower Michigan. Clearly, cold front's already passed up in the Keweenaw Peninsula. You see these lake effect clouds coming off Lake Superior. The Great Lakes are always warmer, effectively, than the climatological air temperature throughout the fall and the early winter. So lake effect clouds, anytime you have northerly flow over the lakes, you should be seeing lake effect clouds. Generally speaking, super cloud free in the cold air. So remember, if you're in 452, there's different flavors of frontogenesis. Well, one of those is a diurnal pulse associated with the cloud cover. So on the warm side of your front, over here in Ontario, it's cloudy. That prevents the daytime warming. However, in the cold air, it's cloud free. This allows heating in the surface in the cold air, and it sort of leads to a diurnal decay in the strength of the front. The opposite phenomenon would happen at night. One way to show this is to go to some surface obs. Give me a sec. So how about we go yesterday in the afternoon. Probably can't see too well, but 16/1, this is in Celsius in Madison. Basically clear skies, so low dew points and a nice day. Mid-Michigan, pretty similar, a little cooler, 14 degrees C, similar dew points around 0. So that's Kalamazoo. Detroit was 14, up in Saginaw more like 12. So similar daytime high temperatures yesterday between Michigan and Wisconsin. And if I move forward to midnight, we've got sort of our cold frontal squall that occurred over La Crosse area and then another one over in Davenport. But you'll notice it's cloud-free over Michigan. This allows for really nice nighttime cooling and allowed for a little bit of an intensification of the front. In the nighttime, Michigan was cooling radiatively to space while everything else was getting rained on. And remember, the rain that falls, if it's 8/8, you know it's saturated, and if rain falls in that condition, evaporative cooling is not super powerful. It's saturated, so you have a balancing between the condensation and the evaporation. So that front is intensifying a little bit overnight. All right, we always like to say the obs don't lie. One of my favorite stations, you guys know the National Data Buoy Center. One of my favorite stations post-cold front, you gotta look at Grand Traverse Light. It's right on the lake. Anytime you want to know what the biggest gust was out of a cold front northwesterly, look at Grand Traverse Light. So here's, let me come down over here. Southwesterlies as early as 10:30 in the morning, 7 to 11 knots. By an hour later, you had 22 gusting 27 knots out of the west, and still further right shift, 20 gusting 24. So not incredible, but that's pretty good. Pretty good cold front. I would say, if you look at the marine traffic though, the mariners, they do not care. The freighters, they still run. So if you're not aware, Duluth is a huge port. Everybody has to go through Sault Ste. Marie, and then they come through Lake Michigan headed towards Indiana. And so the only times that you'll see boats hide in Duluth if there's going to be a big westerly, and you'll see boats hide up in Green Bay if there's going to be a big northwesterly, because they don't want to be caught in it down in Indiana. So if you guys are familiar with the wreck of the Edmund Fitzgerald, this is the time of year when the mariners start to get a little nervous on the deck. So something to think about. Last thing I think I wanted to bring up today is, I was talking to somebody yesterday, it felt like it's been a really, really dry month. So I was thinking about this yesterday in that sort of cold frontal feature that came through, only about 1/10 of an inch of rain, and we've only had 3/10 of an inch of rain for the month. However, since September, we've had 5.5, which is effectively the normal value. So September was pretty much on climatology. October, clearly really low. And from this, let's see, since September 1st, find this right, trying to figure out where the normal value is for the month. Yeah, month to date. So we should have 2 2/2. We only have 3/10. So we're significantly below. We're about an inch and 8/10 low of climatology, and that is actually fairly significant. This is I believe the standard deviations on the bottom from the departure from mean from the 25th of September to October 24th. Anywhere in the red is between 2.5 and 3 sigmas, which is a notable event. 3 sigma standard deviation is quite notable. So certainly a dry October. Why that is, I don't have time for an in-depth investigation of that, but I just speculate we've been kind of been in the boundary where the cyclones are to the north, but the mesoscale convective systems are to the south. And we're just sort of getting the crummy little rat tails of the cold fronts, I like to call them, where there's not a lot of lifting mechanisms, not a lot of strong upper level support, and we just get these little sprinkles when the cold fronts come over.
Even last night, I mean, northern Illinois got 1/2 inch to an inch of rain. We ended up, I think I had 5 100s at my house on the east side. You were talking about the 5 inches that came down in September. most of that came down in like one day. We got like 4 inches of rain in one Saturday, I think it was, or whatever day it was.
Okay.
Other than that, September was pretty dry as well.
Okay. So maybe this will help set up into Andrew's discussion, but one of the ways we can sort of briefly discuss what happened last night is through these sort of broad summary maps. I call this the Sutcliffe-Trember form map, and this, if you take in 452, you know that you can estimate the synoptic scale vertical motion by the advection of absolute vorticity along the thermal wind. Remember, the thermal wind blows along temperature or thickness contours with cold air to the left. So you had a small upper level disturbance over, what's this, Kansas and the border of Iowa and Missouri. You have another one to the north over Duluth. And these are the two main features. And so if you're in Wisconsin, you're going to get missed by both of these features. So there's a pretty pronounced squall over Davenport, Iowa yesterday, with a lot of storm reports actually. And you also had a large region of sort of convective mess just north of Lake Superior, but everywhere kind of in between got missed. One of the other reasons why that squall in Davenport was so potent is that you were able to eke out some more of the water. You might not be able to see it. This is a faint green. It's 1 inch of total calm water vapor. So we just kind of missed it. And yeah, I think that's all for me. So Andrew and I were the same cohort. I guess what it was at 2020. So we spent a lot of time on Zoom chatting with each other, and I think we actually had a Discord channel to do some homework together.
Yeah.
But I don't know if I've actually ever met him in person. So Andrew Quigley, this is Bucky's favorite meteorologist, the National Weather Service in Milwaukee.
Well, round of applause for Ian first and foremost. Ian's being kind. I was just in your shoes in 2020, so I'm just getting the hang of this. And I've had a lot more busted forecasts over my last couple of years in the Weather Service than I have successful. So I'm still learning every single day like you guys are. Yeah, either or works. So I'm still learning every single day, but the cool thing is, as part of my job, I'm kind of looking at the weather data every single day. So just a little quick background on who I am. Ian mentioned it. I graduated as part of the first cohort of professional master's students in the spring of 2021, graduated undergrad in 2020, and I've been in the Weather Service ever since I got done with that. So I had a brief stop in College Park, Maryland at the Weather Prediction Center doing my internship after the professional master's. Then I spent 2 years down in Texas forecasting down there, and then this year, about January, I had the opportunity to kind of come back home to Wisconsin and join the Milwaukee forecast office. So very excited to be here and kind of talk a little bit about our forecast going really from kind of tonight through the end part of next week at a few different things. Certainly not going to be a John Martin level discussion, so I'm not worthy, I can't live up to that, but I'll do the best I can to kind of give you some of the traditional things that you see over on the UW website in terms of model data observations, but as well as some of the tools that I use in my everyday work as a forecaster at the National Weather Service to kind of give you a look into what my forecast process looks like. So we'll start here at time zero. I always tell people that are first getting into meteorology that you can't really, prognose what's going to happen next week, give a forecast for next week if you don't understand what's happening right now. So every single shift I work on the forecast desk, the very first thing I'm doing is I'm looking at the observations, looking at my radar, looking at my satellite, and I'm trying to understand, okay, here's what's going on, what's causing it. So immediately, Ian did a great job of kind of explaining last night's precip and what went into it, so I'm not going to spend too much time there. You can see, looking at the regional radar mosaic, there's not a whole lot there. So we've got some lingering precip there in the Ohio Valley, kind of along and ahead of this cold front. We do actually have some lake effect precip right up there in the UP of Michigan behind this cold front. But everywhere else, here and west of here is very much precip free right now. And it also, passes the vibe check in the satellite as well. So you can tell a lot of the cloud cover affiliated with last night's system has moved kind of from the central Mississippi Valley there up into the Lake Huron vicinity. And we are pretty much severe clear, as we like to call it in the Weather Service, from here west to the Rockies. You can tell we have a little bit of mid to upper level cloud cover here from Montana to South Dakota, but we're pretty much clear. So I'm looking at this, say I'm on shift today, and I'm trying to figure out, okay, what's going on in the atmosphere right now that's causing this. And what we'll see is, first off, if we look at 300 millibars, I'm showing you here the wind speeds from the SPC mesoanalysis page with heights, and then in your magenta is upper level divergence that's going on within the jets there. You can tell, it makes sense why the precip is shifting east rather quickly here this afternoon. You can tell that our upper divergence that was in place kind of over the region last night has now shifted very quickly into the St. Lawrence Valley, and to a lesser extent down into the Ohio Valley. And you can see in the wake of that, we actually have about 120 knot jet streak here that goes from the southern Canadian prairies to the northern side of Lake Michigan currently. And I had to bust out the 452 notes on this one, but if you remember from your jet streak theory, really our preferred areas of upper divergence within these jets are going to be your right entrance region, which is currently sitting along the international border there, Montana, Canada, as well as your left exit that's kind of sitting here over the Sault Ste. Marie vicinity. Maybe I'm just speculating, I don't know with certainty. But that could be one of the reasons maybe why we're getting some lake effect precip right now near Munising in Michigan. There is maybe a brief, or not brief, but weak amount of upper divergence within that left exit region. But more importantly for here locally, as you can tell that we're placed kind of within that right exit region. And we know that that, along with the left entrance region, are two preferred areas for convergence aloft, downward vertical motion in the atmosphere, and higher pressure at the surface. So that makes a lot of sense why we're seeing clearing skies here and really well to our west, because we're under the influence of upper divergence aloft and our column is sinking. One more factor that we can point to understand why the column's sinking here and we're seeing our skies clear out is that front that Ian was pointing out in his part of the discussion has now moved well to our southeast. And if you remember, at fronts, there's really kind of two wings of motion, at least in the vertical, going on at fronts. And you've got out ahead of that front, rising warm moist air. That's why you get your precip at the front. But then you get that transverse circulation of mass up and over the front, and you get sinking behind it. And you can really kind of see that in action here, especially in the sky cover when you place it in terms of the front as well as the wind. You can see that our front is through, so we're kind of in that ascending branch of what we would call the thermally direct circulation from southern lower Michigan down into Indiana. But then you can see the sky conditions really fall off drastically as you get to that front and behind it. You can see, here Janesville is about partly cloudy, but then we go out to the La Crosse area and points west, we're clear. So you're under that influence of upper divergence aloft, but as well as in the lower levels behind that cold front. And the net result is we're having a sinking column here locally in clear skies.
What's going on with that one station in Iowa?
Yeah, no, I don't really know what's
Somebody's
going on there. You might
censored.
want to do a vibe check on that station because it might not be there that much longer if that's what's actually happening. But yeah, so I mean, that's kind of like a good look at what I would do first 5-10 minutes of my shift. Quick, dirty look at the atmosphere, what's going on, and kind of understanding the processes that are going on there. So that's cool. We understand that the atmosphere is kind of right now being driven, by downward vertical motion. It's going to kind of keep us in this clear pattern. But how's that going to evolve, say, into tomorrow night? I know there's a big game going on tomorrow night. How many of you are going, out of curiosity? Yeah, no, I'm really jealous. I'll be not working, so luckily I'll be partaking maybe in some of the alcohols, but I won't be at the game. I'll be back home in Milwaukee, seeing my family. I'm excited to see my family, but truthfully, I'd rather be at Camp Randall watching the Badgers tomorrow night because it's a big one. But I just want to look, now that we understand kind of what's going on with the atmosphere right now, how's it going to evolve over the next 24 hours leading up to game time? So I'm going to show you a couple different charts here, and I should specify what we're looking at in each one. We're going to look at the 200 millibar level of the atmosphere, so we're going to look at those jet streaks, what's going on. We're going to look at 500 millibars for any waves, any sorts of forcing that might disturb the weather here locally. And then we'll look at the surface, and we're just going to do it really from this evening. I'm showing you 0Z here, GFS on the left, ECMWF on the right, and we'll just step through tomorrow evening and see what happens. So I'll do it rather slowly. But what we're going to end up seeing, and I would like to emphasize there might be subtle differences between the two models, but overall, so here we are 18Z today, and if we move into tomorrow afternoon and then closer to game time, you'll see, and it's going to be emanating from an area of subtropical high pressure here off the coast of Mexico. But we're going to have a ridge axis, and a long wave ridge axis at that, building from the tropics up into the Canadian Rockies. And you'll see that our area will be favorably placed kind of downstream of that upper ridge. If we kind of work out the basics of the atmosphere, we know the air is rising out ahead of troughs, sinking down and ahead of ridges. So this is really going to put us, at least from an upper level perspective, in a favorable position to kind of see what we're seeing right now all the way through tomorrow with that upper kind of downward motion continuing. If we look at the 500 millibar level, you'll see this is kind of today's disturbance that's moving through. But then we'll see that pivot to our east, and then we'll get into really not a whole lot going on at 500 millibars. This is 0Z tomorrow night. See, there's a weak little perturbation here that could be at the center of some cloud cover, and we'll briefly touch on that. But really not a whole lot going on. So really nothing in the upper to mid portions of the atmosphere to suggest that anything is really going to change between now and tomorrow night. And if we just confirm it in our surface obs, unsurprisingly, with that kind of upper convergence and downward vertical motion continuing, we'll see high pressure build into the central plains over our area tonight, deepening through 1030 millibars. And then it'll progress, near or just east of that Lake Michigan vicinity by kickoff tomorrow night. So really, how would that translate as a bottom line to what we can expect tomorrow night? Well, we're not going to see anything much different than what we're seeing right now. High pressure is going to be prevailing. The satellite as we see it right now, let me just go back to that real quick. That's the radar, not the satellite. It taught me these things junior year. I've already forgotten. Really, the satellite's not going to look much different, compared to what we're seeing right now. So what does that mean from a forecast standpoint? It's going to be a night game, so we know that it's not quite the same energy as an 11 a.m. Well, with high pressure in our area coming across, really we're going to be expecting light surface winds, mostly clear skies, and we're also going to have a very dry air mass in our area. I haven't been able to show you that, but essentially we'll have a very dry Canadian air mass, across our area in the wake of this cold front that has come through. So nights like tomorrow night are essentially going to be very conducive to what we call efficient radiational cooling. So you're really going to see the Earth really quickly lose any incoming solar radiation from the day, and it's going to go right back out because really there aren't going to be a lot of clouds in the sky tomorrow night to help kind of interrupt that process. So essentially everything that we've got coming in tomorrow during the day is going to come right back out to space tomorrow night. And really, we'll see that effect already tonight. I'm showing you the low temperatures from one of our models that we use in the Weather Service. But we'll see tomorrow night really kind of similar temperatures. Low is probably either a tick above freezing or flirting with freezing right here in the Madison area. One thing I always like to do, just because I'm a weather geek at heart and I like to just kind of look at these things, I really like to see this action kind of in progress when I look at my forecast soundings. So I'm showing you a forecast sounding from the GFS for tomorrow night at 0Z, or 21Z, excuse me, so tomorrow afternoon at 4 o'clock. And you can see we have kind of the action of daytime heating ongoing. The GFS is putting out a raw temperature forecast of 55 at about 4 o'clock. But you can see, and I'm just going to jump our sounding here forward by just one time step to 0Z. You can see how efficient our radiational cooling is going to be. So this is now at 0Z tomorrow evening, 7 o'clock, right after kickoff. We've lost 10 degrees really in about 3 hours, and it's because the sun's gone down and we've started losing that solar radiation out to space. So really my bottom line for any of you going to the game tomorrow night would be bring the jacket, have an extra beer. I don't really care what your strategy is, just you're going to want something to keep you warm because it's going to cool off, and it's going to cool off quickly after kickoff tomorrow night. So that was one thing I wanted to highlight, but I also wanted to look briefly at the pattern going into next week. So we are talking a lot about this kind of early fall, not so early fall, I guess, just our first taste of fall air mass here in late October. But is it going to stick around, or are we going to see the temps kind of come back? So what I want to do, and we have about 15 minutes here, so what I'll do is I'm going to quickly kind of step through tomorrow evening through about 0Z Wednesday, so the middle part of next week. And I'm going to do so at 200, 500, and 850. And what we're going to see, so this is 7 o'clock Sunday evening. Fast forward another 24 hours to Monday evening. You can see we've had a pattern change in the upper levels. So where we had upper ridging over the weekend, that is now migrated towards the eastern seaboard. And by the beginning of next week, it has been replaced by a rather pronounced area of long wave troughing with origins from the pole all the way down the Rockies towards the Gulf of California. And moving through the base of that trough is a pronounced and strengthening upper level jet stream. So you can tell in the upper levels of the atmosphere, we've had a pattern change by the beginning of next week, and that is something we're expecting. But you can tell, just kind of thinking downstream, that some of these dynamics that we've got aloft are going to be making their way towards us by the middle part of next week. Stepping real quick through 500. Again, this is 7 o'clock Sunday. And then 7 o'clock Monday. You can see beneath those upper jet dynamics, we have a rather pronounced area of vorticity at 500 millibars that is just making its way on or near the shore of California by next Monday. And really the thing or the takeaway for this is the impacts it's going to have on the surface here locally. So we know, for example, from our jet dynamics that we're going to have preferred upper divergence here over the Dakotas by early next week, and then back in California. And what we'll see, in addition to those upper divergence sources of upward vertical motion, as well as any positive vorticity advection by the thermal wind in the mid-levels, we're going to see the surface pattern evolve as we move into the beginning of next week. This is Sunday evening at 7 o'clock. You can see the high pressure has moved into the mid-Atlantic at this point. But then you can tell by Monday afternoon, it's still a little disorganized, but you can start to see we've got areas of low pressure that are starting to develop from the Canadian prairies down into the front range of the Rockies. So you can tell that really the atmosphere is going to be in a state of flux as we move into the beginning of next week. It's going to be transitioning. And you can tell from our surface isobars here with high pressure over the northeast, lower pressures in the plains, where we're going to be in a lighter to northwesterly pattern from now through, say, tomorrow evening. We're going to have our winds starting to come back around out of the southwest by the beginning of next week, which is going to be, to the surprise of nobody, will result in a warmer air mass coming our way. I'm going to step back and look, and you can really see this is, oh God, okay, hold on one second, stand by. So you can tell we get to Sunday evening. You can tell there's a warm air mass starting to build out west in those returning southerly winds. And then by the time we get to Monday evening, that air mass has built towards our area. You can see, I know it might be a little hard to see in the back with the color scale, but we've got anywhere between about 12 and 18 degrees Celsius temperatures at the 850 millibar level, so in the lower part of the atmosphere, coming back into our area as that southwest flow picks up. That converts to about 55 to 65 degrees Fahrenheit, so a significantly more mild air mass, really with origins from the desert southwest, will be beginning to work its way toward our area by the time we get to the very beginning of next week. Unsurprisingly, if we go to our high temperature forecast, you can see, so this is our highs for tomorrow and Sunday. You can tell by the time we get to Monday, those temperatures really start to climb up. So basically our operational model that we use in the National Weather Service, the MBM, which just stands for National Blend of Models, has got temperatures climbing back into the upper part of the 60s here by next Monday afternoon. Maybe a few spots in the Wisconsin River Valley, and then perhaps the Mississippi River Valley touching 70 degrees on Monday afternoon. We move forward to Tuesday. This will probably be the day to watch for some potential headlines here locally as far as record high temperatures go. We'll see, moving through another 24 hours, we'll see these dynamics get closer at 300. So again, our right entrance valve is kind of pivoted towards the Arizona-New Mexico border, and our left exit region is kind of pivoted to Lake Superior, with us once more kind of being within that right exit region, downward kind of motion regime. We'll see the same at 500 with the upper dynamics at 500 getting closer, but just a little to our northwest. But then really we'll see the temperatures on Tuesday at 7 p.m. perhaps even be a touch milder compared to 24 hours prior on Monday evening. So we'll be, where this air mass was just kind of getting into our area on Monday afternoon and evening, we'll kind of be firmly entrenched within it by the time we get to Tuesday. And again, we're kind of looking at anywhere between about 12 and 16 Celsius at 850 millibars by Tuesday evening, which again is about 55 to 65 degrees Fahrenheit, which climatologically speaking for Wisconsin at the very end of October is well above normal. So if I'm doing this part of the forecast as a weather service forecaster, this is kind of cluing me in at, what are we going to be looking at for high temps, and are they going to challenge climatology early next Tuesday? And one tool I use to do that is called what's called an ensemble situational awareness table. And this is basically a model-driven system based on the NAIFS, as we call it in the Weather Service. It just stands for the North American Ensemble Forecast System. And it's just a blend of 10 GFS members and 10 Canadian members. And they produce an ensemble forecast, and then there's a model climatology between 1979 and 2009 that can kind of help us once we get into these above normal to extreme weather patterns. They can help us as forecasters contextualize, well, what might we be looking at in terms of record territory in this forecast. And as you can see, I am showing you Wednesday at 0Z, so again, this is just Tuesday at 7 o'clock. I'll scroll down so you guys can see the color table. But essentially what we're looking at, again, these values here that you see are produced on a model climatology running 30 years between 1979 and 2009. And it's looking at every forecast ever made at 4 different times, 18, 0, 6, and 12Z. And it's basically breaking down like how rare are these values that are being forecast. And you can see at 850 millibars next Tuesday afternoon, we'll be anywhere kind of between that 97.5 to 99th percentile. Don't ask me why they put the 0.5s there, it doesn't make any sense to me. But we're gonna be near the top of the climatology for that 30-year value. And then if you look at 700, which is kind of the perfect middle ground between the surface and the upper levels, we've got values that are well beyond 99.5% of that 33-year climo to values that are approaching the max of that climatology. So we're gonna have a very abnormally warm air mass for this time of year in place by next Tuesday afternoon. And unsurprisingly, going to the high temps, we go ahead to Tuesday afternoon. You can see we've got temps from our operational model. It's our operational model, it's not a guarantee. There's several different factors that could help influence whether this verifies or not in either direction. You can tell Tuesday afternoon, we're probably gonna be flirting with 80 degrees here in southwestern Wisconsin. Whether or not we hit those values or maybe not even climb a touch higher will probably depend on things like cloud cover, and that'll kind of come down to disturbances that are gonna evolve over the course of 24-hour periods that we just quite can't see at this point. But the bottom line is we're gonna be well above normal here in Madison next Tuesday as these upper dynamics and southwesterly flow get closer to our area. For context, I have it written down here, I just need to find it. The record high for October 29th, which is next Tuesday in Madison, is 82. And that was set in 1937. And these values here are kind of stacking up against normals in the mid half of the 50s for late October. So at the very least, we're going to be messaging throughout this weekend at the National Weather Service temperatures that are going to be 20 to 25 degrees above normal for late October across really our entire area, which is highlighted right here. But if we say get a little more sunshine than maybe we're thinking early next week, we could be seeing records that have stood for almost 90 years fall next Tuesday. So that's a big storyline. I'm kind of a severe weather nerd, so I don't always get super excited about temperatures and stuff, but when we get into these extremes, like, these are things that I'm paying attention to, and I like to give their due diligence when I'm doing the forecast. Finally here, with our last 5 minutes, what I am going to do is just kind of look at the mid to late portion of next week. Clearly we're going to be well above normal temperature-wise through the first half of the week, largely precip free. But how are things going to evolve, say, getting closer to this time next week? So we'll just step through really 200, 500, and 850 for this. And I'm going to take you through to about 0Z Friday. So this is 0Z Thursday, so 7 p.m. next Wednesday evening. And then step forward to 0Z Friday. You can tell I want to stop and go back the previous 24 hours. So let's stop at 7 o'clock Wednesday evening. You can tell whereas the jet had been positioned in such a way that maybe we weren't favorably positioned for upward divergence and upward vertical motion, you can tell that this specifically right entrance region is drifting ever closer by the time we get to next Wednesday evening, and then moves basically directly overhead early Thursday morning and then into Thursday afternoon. So that checks one box for something that maybe I'm looking for precip by the time we get to next Wednesday, next Thursday, because we've got that upper support. If we look at 500, this is 7 o'clock Wednesday afternoon. You can tell that we're still kind of seeing a lot of these vortmaxes, vorticity maxima I should say, positioned a little to our west, though they're getting closer. You can tell then certainly by the time we get to Thursday morning, afternoon, those eventually push over us. So we've got upward vertical motion in the upper levels, upward vertical motion in the mid levels. And I'm going to use 850 here as a proxy for the surface because we got the temperatures. But you can tell also as we move into this period, so this is Wednesday evening about 7 o'clock, you can tell pronounced area of baroclinicity is draped either near or just northwest to our area, along with those upper dynamics that are moving overhead. And you can tell it works its way through the area by Thursday evening, again about this time next week. So what's the point there? We've checked 3 boxes for upward vertical motion aloft, in the mid levels, and in the low levels, because we're going to have a frontal passage. Means precip's probably a pretty good bet by the time we get to, say, next Wednesday and into Thursday. And that checks out if we move ahead here on our precip forecast. So what I'm showing you, I'm not showing you any simulated reflectivity here, I'm just showing you a QPF forecast, just a forecast for rainfall. And this is starting at 0Z Tuesday. But you can tell here, this is 0Z Thursday, so 7 p.m. Wednesday. You can tell rain starts to overspread the area. And you can tell even some heavier pockets of rainfall move through the area late Wednesday night into Thursday morning. And then perhaps we're drying out by the time we get to Thursday evening at this point next week. So, while we start the week next week likely well above normal, potentially record-breaking territory on Tuesday afternoon, we will see that pattern break down by late week, and we'll probably get some precip. Now, how many of you are into severe weather in here? Totally cool if not. I won't hold it against you. Okay. So I am too. So when I'm thinking, about this, we're gonna have pretty dynamic setup here with an upper jet moving overhead, good forcing in the mid levels, as well as an abnormally warm atmosphere out ahead of it. I'm starting to hear some alarm bells maybe for some potential for severe weather, at the very least severe thunderstorms. And I would say at this point, it's kind of a mixed bag in terms of if anything we see next week along this front could elevate to severe levels. I'm showing you a Cape forecast here from the GFS. This is next Tuesday afternoon and then next Wednesday evening. And you can see there's some weak signs of elevated instability there. So, it's one of those things that we'll have to keep tabs on based on, cloud cover, how the timing of all of these features work through. You can tell there's some elevated instability in our forecast sounding, particularly above the boundary layer. But right now, it looks kind of iffy in terms of if any of that convection, severe, or thunderstorms, if we saw it, would be severe. So that is where I will stop. But yeah, really the key takeaway is it's going to be cold tomorrow night. We'll be well above normal by the beginning of next week, and we'll see a pattern change by the end of next week, perhaps a few thunderstorms.
All right. Thanks.